James?
All right. Uh, Thanks everybody for coming. We are joined by Jerry Lynn of JHL Violins. Jerry, you thanks for coming. You were on the Luth Group interview with Ian a while back, and
Yeah,
we did a deep dive into your Instagram feed.
we
Um,
did three of those.
did we do three?
We did
Wow.
three.
Yes.
I'm pretty sure they were all, I was there for all of them. I apparently
You were. We
find them all,
chatted every
all the time.
time.
Yeah.
It's all good.
No, that's right. And there was a ton of cool stuff in your feed, and we kept coming upon pictures of the little patches that you make for when you have torn or missing wood.
Mhm.
At the time, you didn't have internet in your shop, so we were left to use our imagination. But since then, you have internet in your shop, which means you can join the Leap Along whenever you want. Uh, and also, we get to see the process for scanning and making the patches.
Yeah, for sure. So what I have for with me today is about 2 weeks ago, I did a presentation for the American Federation of Violin and Bow Makers about how to get into 3D scanning and CNC milling. And unlike times where I've talked about this in the past, this time I actually talked about costs and recommendations. Um, so this talk is largely geared towards them, and I apologize if there's a lot more violin-centric stuff in here than there would be otherwise. But I think a lot of it's applicable across the board. I do have my scanner set up. I've got my mill turned on, although I don't really have any project loaded up in the mill. If anybody wants to see it, I can go over there and we can talk about that as well. So
What
I guess
makes a
without
true
further ado, um, let's let's figure this stuff out. So this is getting started with 3D scanning and CNC milling, or how to ruin things faster with technology. So what is it? The process of digitally capturing a void and part of an instrument, creating a positive to fill that void, and using a robotic cutting machine to produce the part to fill the void. Just as a side note, I'm not the first. I'm not the best. Um, I happen to be the guy that's willing to talk about it a lot, and I've helped a lot of colleagues get set up with this equipment and got them going on that. I think at this count, I'm up to like 7 or 8 people I'll call victims that I've worked with heavily in order to get them functioning with this stuff. Incidentally, probably the first people to use this sort of technology were actually dentists. In the 70s and 80s, they were using very rudimentary intraoral scanners to produce crowns. And today's same-day crown industry is largely based on the stuff that was developed then, and we're essentially borrowing that technology. In the violin field, in the early 2000s, mid 2000s, there was a fellow in Germany named Andreas Jacobi who kind of ridiculously patented the process, which is kind of funny because dentists, like I said, have been doing it for a very long time. Consequently, there was a lot of people doing this, I'll say underground, particularly in Germany and in other parts of Europe. Um, it's only recently that the cost on a lot of this stuff has come down to the point where it's reasonably affordable. But anyway, we can really thank dentists for this. How I got started with this, um, back in 2017, I started my own business, and I quickly realized that a lot of the jobs that were being sent to me were jobs that nobody else wanted. And they were jobs that nobody else wanted because there was lots of problems with them. There was tons of missing material on the inside, largely from people removing tops. Usually when you remove tops, you try to be as gentle as possible. You try to make it as easy on the instrument as possible. And I was getting instruments where it was clear that people just ripped them apart. Lots of missing material in the under edge. That's the part where the top plate meets the ribs. And it was kind of disheartening because I was spending a lot of time trying to very conservatively rebuild these edges. and I wasn't really getting paid for it. So I had remembered that through the Oberlin Restoration Workshop, I had met a guy named Sam Payton, and Sam's an instrument restorer for a while. He was the workshop head at Teresio. He now owns Payton Violins in Rochester, New York. And he had started experimenting with 3D scanning and CNC milling, I'll say in the 2010s, like 2010, 2011. He had built his own router. He was kind of heavy into this stuff. And I really wanted to get involved in it because at this point, it's like, okay, I need to stay in business. I need to be in business, but these things are in pretty horrific shape that I'm being sent. So I asked him for a recommendation because I think at this point he had spent 70 or $80,000 total on every piece of equipment that he had. I was like, I don't have that kind of money. And so he recommended up in the top picture there, he recommended this tiny little machine. It's the Roland MDX-20, and it's from circa 1999. It has an area of 6 inches by 8 inches that it will cut. And it also has scanner functionality too via touch probe. He said, get that machine. And Sam's a great guy. He is really friendly. He's super, super smart. In fact, I'd say he's smart to the point where he doesn't realize that people don't necessarily understand the things that he understands. So I went out and I bought this machine. Um, I spent $900 on a structured light scanner made by the David Company. This was their SLS1, and I spent about $400 in what ended up being a stolen computer. I learned that by when I needed to have some work done on it. The Windows that was on there was cracked, and yeah. But anyway, I spent about 3 grand combined, and I went about scouring the internet as best I could, learning and piecing things together from internet forums. And the result is what I'm able to do now. Probably the best way to allow you to understand the process is to take you along on a job. So the process is first we're going to capture data, data being anything that you want to recreate. Next, we manipulate that data. Finally, the data that we've manipulated, we place it in a world coordinate system, or uh, making it right with the world is another way that I like to describe it. Finally, we take this data and we come up with a CAM strategy for it. Next, we prep stock and set up the machine. Finally, we cut it, and then we remove it from the rest of the stock and glue it in the instrument. Let's go along for a job. This is an instrument. It's a late 18th century Mittenwald violin. It's got all manner of horrible things done to it. Uh, it's got so much wrong with it that it's really not worth restoring, because by the time I put tons of labor into it, I wouldn't get out what I put into it. So therefore, nothing's ever going to happen with it. It's going to sit in a drawer and it's going to live there. But the beauty of this instrument is I've used this now several times as a training instrument when I travel to people's shops and I help set up their equipment. Um, it's got a lot of tear out. This happens to be tear out in the bottom block area. And normally how you would deal with this, it's shallow enough, I guess. You could use fill, but a lot of people would prefer to have some sort of patch put in place. So structured light, and we'll get into other types of scanning, but a structured light scanner, all it is you have a projector and a camera. The projector beams a pattern of light onto the image. The camera reads the light patterns, and from there, the computer software then determines things like depth and measurement and everything that would need to be had to create it digitally. Right here on the right of the screen, you see the structured light target pattern that's produced by the software that I'm using. And then on the left, I have it just for funsies. It's the calibration panel. generally all scanners need to have some sort of calibration process. Some are very fast, some are very slow. Generally, the more money you have, usually the faster the calibration is. The type of scanner I'm using right now is really considered to be outdated technology, and it was also very affordable. So I like to call it high accuracy, low convenience. And this just happens to be a shot of the calibration panel and after it's been calibrated. So the structured light scanner, as I said, it beams a pattern of light across the area, and it reads that, and it gives you a.
No, seriously, you can see it right now. You have to get out here. Jerry, the cloud is going over it. Come on.
I'll be right back.
Okay, we're gonna pause a minute while Jerry goes and observes the eclipse. The recording we can cut away.
Anybody feel like producing any incidental music while we're waiting? Mike Schramm, are you there? I know that you can. You wanna play us a little Mike Schramm?
This is called the intonation blues.
Okay, I'm back.
That was it.
That was it. It was just quick to see.
Feel free
Okay.
to take longer if you want to go enjoy
No,
it.
we're good. I'm good.
Uh-huh.
Good.
And you can
Are we
still
good to
see,
go?
huh?
Well, I had glasses on. So anyway, what you're going to see here is um, the structured light pattern being beamed onto the top of the instrument. That's it. And with one single shot, this is the image I have. You can see all the grain lines. You can see every bit of detail. If you're not careful, you can even see pieces of dust. Um, this is another view of it. So you can see the depth of what's missing. And
So
Wow,
just to
that's-
clarify, this is not a picture. This is in your modeling
yeah,
software.
this is in the structured light software. This is the image captured from the structured light scanner.
And that was
That's
real time.
crazy.
Sorry?
And that was real time. It's that quick.
Yeah. Let me exit, go back,
That's remarkable.
and like I said, this is outdated technology. The new stuff, which will use various spectrums of light, and we'll get into that. Most of those units tend to be handheld and they have automatic tracking, so it's filling in the image as you go. I don't necessarily like that for this sort of application, largely because most of the low-end scanners that are coming out today, or even the high-end ones, are not geared for objects like instrument plates. So you end up with more data than what you really need and just more information. And this I find gives me really beautiful results, and I can work with it. So this is it. This is the data. That was as fast as it is in order to get information that I need to manipulate it. And from there, oh well, here we go. Options for data capture. That was the next thing we're going to talk about.
Okay.
So SLS, structured light scanning, there's different versions of it. The one I'm using here is made by the HP company, which was originally by the David company. David was a company in Germany that HP bought out. After they bought it out, they continued to develop the product for another 2 years, and then in 2019, they killed the product. Probably one of the reasons why is, again, that has to do with that whole high accuracy, low convenience aspect of this technology. Whereas a lot of the new stuff that's coming out by makers such as Creality and RevoPoint, for most consumers, does 90% of what they're looking for at a cheaper price point. and they use other spectrums of light. So this is white light. This is every bit of the visible spectrum, which isn't really advantageous when you start talking about things that are shiny or black. When you start to have things that are shiny or black, like varnish, it can be really difficult to pick up detail with a white light scanner. And so you start to move into other spectrums like infrared or blue light, and all of a sudden things that are shiny start to become a whole lot easier to see. So for people wanting to scan, I don't know, Pokemon figurines or parts of a car, those types of scanners are a whole lot better. Whereas for somebody scanning something on their desktop where they really want a whole lot of detail, they don't necessarily offer that. Another type of data capture is photogrammetry. In fact, there's a shop in Switzerland where they're actually using their cell phones and an app called Polycam to do this. I've seen the scans. I'm not 100% impressed with it yet. I think another 4 or 5 years and it will really be mature technology, and it might be able to do just what we need it to do with just your phone. And this software. I think the software, it's a subscription. I think it's $100 a year. If you're just getting little models out of it, if you want to do figurines or whatever, it does an absolutely beautiful job. But for needing accurate, high resolution data to fit a patch with it, I'm not convinced yet. Another way of collecting data is with a touch probe. I'd mentioned that the Roland MDX 20 that I'd purchased came with a touch probe. In fact, some of my earliest scans, the one that was used for the promo of this talk, was actually done with a touch probe. And what it is you have a grid system, X, Y, and Z, and that probe is a switch that when it hits an object, the switch is hit, and that creates a point in what's called a point cloud. There's a there's not a whole lot of advantages to this, except for it's kind of set it and forget it, which is why I still sometimes use it. Seen here, it is being used with a polymorph cast of a patch bed. Polymorph, sometimes called Instamorph, friendly plastic. It's stuff that, unless you hold it under compression while it's curing, is not very accurate stuff. But if you hold it under compression, it's extremely accurate. So this is one of my first forays into scanning was using this touch probe scanner. A lot of CNC control systems might have a touch probe utility, like I'm trying to think of the Mach 3 has a touch probe scanning capability. I think Lennox CNC does. I think there's a couple other ones. Or you can even write macros if your machine allows you to write macros for the G code. If you have a standard touch probe that's used for touching off work, you can also do limited scanning with that touch probe. And finally,
So in this example, you're making a cast with the polymorph, which is
correct.
the same thing as friendly plastic that we
Yes.
use. Yeah.
Yes, and I'm using dental foil as a barrier between the polymorph and the raw wood. If
I
you
see.
don't, it will stick and it'll make a heck of a mess. I
Right.
learned this trick from Joe Grubaugh and Sigrun Seifert. They have this neat process where they make a positive and negative using polymorph, and then they'll crush summer growth wood between it in order to fill a void in the top of a plate.
Ah.
It's pretty ingenious stuff. I have pictures of it buried on back of my Instagram, the process. But when I first did this, I sent Joe Grubaugh, who was a friend of Frank Ford's, by the way. That's how I found out about Frank Ford, was through Joe Grubaugh. Because Joe borrowed a lot of stuff from Frank and vice versa. So I sent this to Joe and I said, "Hey, thank you." And it's pretty miraculous stuff, or pretty miraculous process to use it under compression.
Yeah.
Finally, the last way of data captures with photographs. There's a lot of repairs that you can do, particularly on instruments, like let's say old school button patches, button graphs, where you're cutting straight walls. you don't necessarily need a scan. You can use it for photograph. And as long as you know the geometry, you can scale the photograph in a program like Fusion, and you can draw a part and you can drop it in. So that's why I consider photographs being a form of data capture.
And if you're doing, is that a process that you use?
I do sometimes, not often. My friend Greg Sapp, who I keep telling Ian, you got to have Greg Sapp on. Greg used to do a lot of stuff with photographs, and I think he still does. His shop works on everything from the cheapest of cheap things to strads. And for the cheapest of cheap things, he's really has some ingenious repair processes where he will, using an overhead router, rough out patch beds, like on things like button patches, and then he'll just take a photograph of it, or since he's using a template, he'll just have the template, saved as a file, and he'll use that to machine a new part into it. So it's done. It's
Yeah.
not necessarily. It really is something that needs to be done with known geometry.
Yeah.
Otherwise, the scanner is the way to go. So my recommendations for scanners: buy an older HP or David system. You can find them on eBay for like $1,000. Make sure it's got all the parts with it, including calibration panels. If not, you can print calibration panels. That's kind of my low end recommendation. I don't think you don't necessarily take my word for it. If you want to look into scanners like the Revo Point Mini, and like the Creality Seal, go onto their Facebook groups and look at the results that they're getting. And remember the results you just saw. The results that they're getting are nowhere near as good by, I'll say, normal users. There are people whom are using them for image capture. They're taking hundreds of scans, and then they're importing the cherriest of scans into a software like Meshcam or Cloud Compare, and they're putting scans together there. It seems not easy. So I'm of mind, like a lot of those low end scanners just aren't there yet, but they all have groups on Facebook. Go check them out, see what they look like. Even a lot of the lower end options from let's say Shining 3D, who makes the Transcan C, which we'll talk about next. Um, I have two friends who both bought the Einscan SP, one in Washington State and one in Michigan. The one in Washington State gets amazing results with it. And for whatever reason, the one in Michigan, the results are awful. And we can't figure out why. Uh, Systems are similar, scanners are similar. One is amazing, the other one's awful. The ones, if you've got deep pockets, and I've heard rumbles that it might be discontinued because whenever you make something great, it's always end up you discontinue it. That seems to be the case. The Transcan C from Shining 3D. I've got a number of friends and colleagues who work with this. When I first saw this come out, I mentioned to my friend Gen Sato at the Rooting Shop in Boston. It's like, this looks like the ticket. And they got enough money that it was just like, okay, and they bought it, and it was beautiful. And then a friend of mine in Chicago who teaches repair at the Chicago school, he got this exact same thing, and it is right out of the box, super easy to calibrate, super easy to use, and amazing resolution. It just costs almost $5,000, which sounds extraordinarily expensive, but when you start looking at other pro scanner options, this is cheap. Like the ones that are made by like Artec and the higher end versions from Shining 3D. Those start at like 12 or 15,000. This is good. The Einscan Pro, which I think costs around 7, is also good. That has some handheld capabilities, or you can use it on a desktop. The other way, if you are adventurous and not scared of technology, you can create your own 3D scanner. Since this is just a recent phenomenon, I mentioned how HP bought the software and the rights to use it from the David company. They then killed the product. Recently, a lot of users of that, their license dongles have started to die. And they got tired of having people contact them saying, hey, how can I get a new license for this? They just put the software up for free. This was for the last 2 months. So you can literally download this software. If you scour the internet, you will find things on places like 3dscanforum.com and some other options. We'll get into those in a second. And you can make your own structured light 3D scanner. There are also tutorials on YouTube about how to modify a projector. So the projector, if I put my phone up here, this is it. This is all my structured light scanner is. I have a second camera that I will use with this, but this projector is not stock. This projector has been modified so it can be used up close to objects. Normally, projectors are for throwing something across many feet in order to watch things like a movie or a presentation. They don't focus up close. There are tutorials on YouTube of how to modify projectors so they work up close. Most of the things that you can use to mount a projector and a camera on are just photographic equipment that you can get from B&H Video. So you can use HP software or the other option that's out there. And someday I'm probably going to do this, and I'm going to end up on an NSA list if I'm not already. Modified FlexScan. FlexScan is made by a company in British Columbia called Polyga. They used to offer this software for a fee. It cost $500. You buy it from the company, and you could roll your own 3D scanner using their software. However, I think they quickly realized that they were losing out on sales of hardware. And 3D scanners at this point are definitely, you make money on the hardware and not the software. Seeing a missed opportunity and wanting to help people in parts of the world that aren't necessarily as rich as America and Western Europe, there's a guy in Iran of all places named Nasir, who I don't know if he has a relationship with Polyga or not because they haven't seemed to try to shut him down. And in fact, this community keeps growing. He has a modified version of FlexScan that he sells, and it's modified heavily enough that the functionality of it is a lot better than what Polyga was selling. He made it compatible with a whole bunch of different cameras. He made it faster. He made it work with different light spectrums. And I'm told he also offers amazing tech support. You find him via his Telegram channel, which I have on the right-hand side. In fact, it's a great place to even just learn a lot of stuff about 3D scanning because there's people there from all over the world that are doing some pretty amazing scanning stuff that you can go and just you can be a fly on the wall and just absorb all this stuff. And I regularly do that. There's a lot of tips and tricks that I've picked up from those people. So you can roll your own if you're adventurous and you're on a budget and you want really high-end results. That's the option that I would recommend doing. However, it's not from everybody. If you've got deep enough pockets and you want something that will work right away with little fuss, the Transcan C is where I would go. Or a middle ground is to find an old HP or David system. That still is kind of in itself frustrating. A colleague of mine, a good friend of mine, she tried to learn it without me, and I kept getting phone calls and text messages like all the time saying, "This is awful. This is awful. I can't do this." And it takes some finesse in order to get it to work. But once you do get it to work, it works really, really well. So if you roll your own, let's say, you're going to have the problems of getting something to work which doesn't exist yet, plus learning the software. It can be done. There's tons of information out there on the internet. It's just going to take a while. The data manipulation. So if you remember, we took the scan. Next, we've got to trim the scan, and we have to invert the faces or fit the faces, depending on what software you use. So we have the scan, it's a negative, right? We want to turn it into a positive. And the other thing that we probably are going to want to do is lower the polygon count. What that means is these scans, computers don't see round objects and they don't see it as round. What they're doing in order to make a 3D file, it's a whole bunch of straight lines that are chopped up in the forms of multi-sided polygons. And the more polygons you have, generally the more detailed the mesh is. It's called a mesh because if you look at these polygons that they're put together, it looks almost like a mesh bag. So a lot of these scanners, with exception of maybe the highest of high end, they make up for, I'll say, maybe less elegant code or less elegant way of coming up with a 3D object by just bombarding it with data. And you end up with these meshes that are massive, and we'll see that in a moment. So trimming a scan, a lot of software that's used by the 3D scanner itself has trimming functionality. These are screenshots from the HP 3D scanning software. And all I'm doing is I'm using their cleaning tool, and I'm chopping off sections of it until I get to what I want. And what I want is the picture on the right-hand side, which is just I don't know, looks like some sort of weird croissant. That's the patch that the area I want to create a patch of. From there, this is a program called MeshLab. MeshLab is open source software. It's free. It's extremely powerful. It will do more than you would ever possibly need. Maybe not necessarily in a way that's as easy as other pieces of software, but it gets the job done. Here, the first operation I'm doing is I'm inverting the faces. And to do that, I'm selecting under filters, the normals, curves, and orientation tab, and then I'm going to invert faces orientation. And as you can see, what was a negative is now a positive. If you look at um, the object that's in front of you on the screen, the bits that are the high wall that's sticking up, I don't know if I can highlight it here. I can't. Anyway, that was
Can you
the
see my
edge.
cursor?
Sorry, I
Can you
can't
see
see.
my cursor on the screen?
No,
Oh,
hold on a
okay.
second. I mean, now I can see mine.
Okay.
Uh, all this business here, this is the edge where the saddle, um, where the plate stops, and the saddle would rest against this. And this was a negative, and now it's positive. And I've kept that largely for registration. When we're fitting patches by hand, a lot of times we use helper cleats, or if you're if you're from the UK, you might call them studs, in order to keep registration when you're fitting a patch. So that means when you put the patch in and take it out, it goes to the same place every single time. The When you're doing this with a computer and a machine, sometimes, a lot of times you don't necessarily need any registration, but it's a nice, comfy thing to have. Uh, it just helps you visually to know that I've got this in the right place when you get it hot and wet with glue and you clamp it. Um, it's just really handy to have some sort of registration aspect to it. And so I've left that ledge there for registration. So I've inverted the faces. So that file, that raw file, uh, just for funsies, I wanted to see how many megabytes it took up. That raw file is 70 megabytes. It's not very big at all. Um, I mean, heck, I don't remember how many, I'm sure that's, a nice size album of somebody's music. That's 70 megabytes. It's a lot of data. And if we look at the number of faces, faces are I mentioned about polygons. Faces are the flat spots on those polygons. It's got 1,469,432 faces. I know from experience that with a patch that size, I want to have that below 10 megabytes and below 100,000 faces. As otherwise, um, things start to bog down. When we start to look at CAM software, Not all cam software can handle meshes that are that big. Some can, like trying to think of Desk Proto. It's a company in Germany that makes a really friendly cam software. It can handle massive meshes, but a lot of things like crap out, like mesh cam craps out. Fusion doesn't like it. I think Rhino cam starts to have issues with it when they get too big. So this is just excess data we don't need. More data is not more better. In fact, more data is oftentimes more detrimental into having an easy time dealing with it and getting it cut. So we're going to lower the polygon count. And to do that, back in Mesh Lab, under filters, remeshing, simplification, and reconstruction. And then we're going to go down to quadratic edge collapse decimation. I have no idea who names these things, but that's a mouthful.
Sounds great.
It sounds great, doesn't it? Like I want to order that at a restaurant. That's how great it sounds. So anyway, we're going to hit that, and you can specify the target number of faces. I can go right in there in the target number of faces, and I can type in 100,000 and it'll do it. However, I always figured that the computer program is going to do a better job with math than I ever would. So I just keep it'll always divide it by two. So I just keep hitting decimate faces until I get below 100,000 faces. And then I export the file. Now, if I look at the size of the file, I went from 70 megabytes to 8 3/4. I mean, that's a significant savings. And you look at it, you pull it into whatever software that you can do meshes with, you see literally no difference. And that's because that raw scan has polygons on polygons on polygons on polygons just interwoven, and it's just a stupid amount of data that doesn't translate to anything in the real world. So we're going to get rid of them. Software and costs for trimming data and manipulating it. Most scanner software includes trimming functionality. Mesh Lab is free. Blender is free. There's a couple other ones that you can do this with that are also free. Fusion 360, free for hobbyists. Those of us who pay for a pro license, it's going up to 680 this year. Hey. Rhino 8, I believe, is currently 995. That's a one-time fee. Later on, we'll talk a little bit about different forms of software, and I know that's been touched on a lot with 3D Club. People have their favorites, and it ends up being a Chevy versus Ford pissing contest. Really, at this point, they all can do what you want. It's just finding the one that works best for you. And I happen to be a Fusion guy. I know a lot of people in the violin business who are Rhino people, and after a while, well, Rhino does that better. No, it doesn't. Well, Fusion does that better. No, it doesn't. It's all kind of the same thing. It's just what works for you.
Yeah, we have a lot of that rivalry going on, and it makes it difficult to hold classes because
it really does. It really does. It's not even mentioning SolidWorks. If you follow, trying to think of what his name is, Barnes Guitars, Barnes Guitars on Instagram. Richard Barnes, amazing guy. He's a heck of an artist. He draws like a Renaissance painter. He used to do a lot with Baroque instruments and like things like gambas and Baroque guitars. He ended up taking a machining degree at a college in Southern California. And he was so good that he's now on staff there. He teaches CNC machining and manual machining. And he's a whiz at SolidWorks. And if you've ever used SolidWorks, we're kind of having rivalry here with Fusion 360 and Rhino. SolidWorks is not something that's necessarily designed to create organic objects with. And he's drawing violin plates using SolidWorks, and it's amazing. It's just because it's what he's used to. He just does it. So yeah. The whole argument of which is better is kind of pointless. Next, so we have this data. And if at any time we need to go back and have a recap of all that, because I know this is a lot of information, we can. I can rewind things back and we go over it again. So this patch is now just floating in space. It's got nothing to ground it to anything. And James got to experience that. I sent him this exact file in order to play with, and it just loads like it's stupid. It has got no orientation. Um, we have to think about how that's going to be cut out on the machine and how that's going to live on wood. So, for instance, I decided a while ago that most of the time I had the best luck with spruce if I line spruce up with the y-axis of my machine. And so therefore in the computer program, I'm going to line the grain lines of that spruce up with the y-axis. So aside from that, I want the parts to meet at the XY plane with the bottom of the part as close to Z0 as possible. And that's largely because when I enter it into a CAM software, I don't necessarily want to have to do a lot of positioning there. So there's a couple pieces of software that can do this. MeshLab does it, Fusion does it, Rhino does it, Blender does it. You can use all these to manipulate a mesh to make it make sense within a world coordinate system. You also need to pay attention to special overhangs and wood orientation. So um, if you have a part that has an overhang or an inset, you have to position it in such a way that the cutter can get to it, which often means preparing your stock in a way that isn't advantageous. For instance, I might have to explain this a little further. When I was first getting started with this, I had an instrument that there was no platform for the upper block where the neck gets mortised into. It was just the instrument was an expensive instrument. The person paid a lot of money for it, but the block was just floating in space. Like here was the edge of the plate, here was the block hanging over it, and I thought to myself, I was going to be a hero, and I was just going to fit a block using a CNC machine. And so I had to orientate my block wood so it sat in the right way for the machine to cut it. Later on, I figured that was not such a great idea because if somebody ever needed to remove the back, they would hate me. But again, you've got to think about how that part's going to live on wood. Are there any special circumstances that you have to prepare your stock? And this all relates back to how you get the part to relate in the world coordinate system, how you make it right with the world. For instance, this is I'm not a Rhino user, but I have this piece of software that I oftentimes use when I'm in a hurry. It's called 3D Editor. It was made by Roland. It's so old that the user's manual for it, the actual paper user's manual for it, talks about Windows XP being this new great thing, and that's what the latest drivers were for. So the thing I like about it though is it shows a nice four-screen view, kind of like Rhino does. So this is what it looks like when you just load it into a random piece of software. It's just this strange little taco shape that's just floating. And what I want it to look like is this. In the upper left-hand corner, you'll see the grain lines are all running in the y-axis, and it's sitting pretty level in regards to like the XY plane. If you look at the lower two screens. And you can also see the little bit of ledge that I've left for orientation sticking up in the back. Software cost, exact same as before, because a lot of this stuff has dual functionality. So far, let me back up a little bit, just in order to keep things. We go back all the way to the process. Data capture. We use 3D scanner. Data manipulation. We trimmed the area that we wanted to create a patch of. We inverted the negative into a positive, and we've placed it in a world coordinate system. A little bit ahead of ourselves here, if I go back down to where we're at here. Before I set it up, and you could go either way with this. Sometimes I'll set the stock up but probably I should be better if I did cam first, but for the purposes of this, I did the stock setup. You want to align your grains with the chosen axis. And for at least for violin family instruments, you generally want to have the grain that you're putting into the instrument running the same way and in the same manner as the grain that's already there. And a lot of this has to do, this really has to do with two things. One is your hope is that expansion and contraction of the new pieces of wood are going to be similar to what the wood that's already existing in the top or back. The other thing is, and this is something that's changed over time, there was a school of thinking that patches should be put in with an offset to the grain lines, meaning they don't run perfectly straight, they run at a straight angle. And that was thought that it would be stronger, and it probably is stronger. However, we're seeing instances where kinetic energy, meaning when the instrument's dropped, that energy travels through the plate in really strange ways. And so if you've ever had an instrument that's been dropped that's had a patch in it where the grain is going off axis from the other grains, a lot of times you end up with a strange compound split. So the thinking now, at least with a lot of my friends, is we put it in the exact same way that it runs with the rest of the instrument, not only for expansion and contraction, but also for should the instrument be dropped, you're not going to cause any more harm than it's going to have just by the fact that it's being dropped. Choose stock of appropriate thickness and close to having parallel faces. So a lot of times we like to use split wood in order to avoid run out. You want to have it then so both sides of your stock, one isn't sticking up one way or the other. And that's so when you stick it in the machine, you either don't have to face it in the machine, or if you're not facing it, the cutter doesn't run into a spot that's really high. So parallel face is how I choose to get the stock ready to go into the machine. And a lot of times when we fit patches, um, a lot of folks use a plywood backer. And what that is it allows you to have a thinner piece of wood as patch material and have something to hang on to it with plywood. If you try to attach it to the plywood while you're cutting it out, and then cut both the patch and the plywood out later to glue it, you'll end up with a patch that doesn't fit, and that's because plywood has stress in it. If you cut them both out at the same time from your piece of stock, which we'll see what the piece of stock looks like in the future. I hope I have that in here. You'll end up with a warped patch because the plywood's going to move. So for folks who want to use a plywood backer for whatever reason when it comes to gluing, some people seem to always feel the need to have one. I recommend cutting it out separately from the patch. That's one of those things that I mentioned that talking this to violin folks is a whole lot different than talking this to guitar folks, because I don't know if there's a tradition of using plywood backers and patches for guitar people, so it might not make a whole lot of sense for you folks. And finally, with the stock setup, we're going to fixture the stock in place. I mentioned that I want to have everything lined up with the y-axis. I have a way of doing that I think is pretty straightforward. You could use let's say a square against the table of your CNC machine. However, I often find that that's to be unreliable. For the purpose of demonstration, if we look on the left-hand photo, the wood that's in the upper part of the screen would be wood that's appropriate to use for the instrument that I'm trying to make a patch for. However, it's so fine that you wouldn't necessarily be able to see it in photographs. And since this is just a demo, I have it rigged up with this much wider piece of wood. And what I've done here on the right-hand side of the screen is I've attached a machinist parallel to the wood. And I've just done that with double-sided tape, and that parallel runs exactly in line with the grain lines. From there, I've placed it on the MDF spoil board that I have in my machine. And on both sides, those are lead ingots. That was a gift from a client who saw me weighing down a some sandbags with hand planes I put on top of it for extra weight. And when he came back 2 weeks later to pick up his viola, he came in with 50 pounds of epoxy coated lead weights. And here I'm using four of them. It's the most bizarre gift. Like I'd rather have baked goods or wine, but this ended up being like one of the coolest gifts ever. I'm using four lead ingots on either side of the piece of wood, and this is to allow the wood to float, and also to provide me a means of tapping to get the parallel to run in line with the y-axis. You'll also see an alignment pin. That pin, in order to get things aligned, is I've got it close to the top of the stock, and I've ever so gently got it so it's touching the parallel, and there's no light gap that exists. And then what I'm doing is I'm jogging the machine forward to the front of the parallel and hoping that no light exists in that light gap. If there's a gap, that means that parallel is not running with the y-axis. So I'm going to tap these little lead ingots around until I get it so there's no light gap that exists at the back of that parallel or at the front of that parallel. You can see here it's at the front. There's no light gap. And from there, on the right-hand side, left-hand side, I'm using a pencil. I am outlining that piece of wood. Most of the time, the stock that I'm grabbing out of my wood pile, it's not square. So that's handy for a reference surface, a reference line, is I can then draw around that wooden piece of a piece of stock. And now I know where to put that piece of wood on the spoil board when it comes time for cutting. For fixturing the stock in place, there's a lot of different ways of doing this, either through sheer laziness or convenience. I still use double-sided tape. That's heavy-duty carpet tape. You can also use blue tape and super glue. That's another one that works really, really well. Where this is just sold at the big box stores as carpet tape. It's voraciously strong. It would take an awful lot of cutting force in order to rip that up. So it works fine in this application. We'll get to the CAM software a little bit in a moment, but I've set up the work offset to be on that corner, and I've done so knowing that I need a certain amount of stock on either side. This isn't necessarily the most accurate way of setting up work offset. Let's say you have a very specific piece of material that you're going to cut something out that you want to flip it over later to do something on the other side. You'd want to be very specific on how you set your work offset. All I'm using this for is I know I've got extra material. I've set my work offset up on the stock in a place where I know I have extra, and I'm just eyeballing it, putting the cutter over that little X, and I'm eyeballing it in place so that I know that it's good to go. And I'm hitting X, Y, 0, and eventually Z 0 on that X on the machine. And finally, we get to CAM. In recent decades, CAM programs have become a whole lot more accessible. CAM is computer-aided machining or manufacturing. Probably with this group, I don't necessarily need to explain it all that much, but for some folks, the acronym that eludes them. So computer-aided machining or manufacturing. In recent years, things have become a whole lot more accessible. It used to be that you needed to know a lot of G code in order to program a CNC machine. Now you don't really need any. With options like MeshCam, DeskProto, and SRP Player. MeshCam is a company based in California. It's super easy to use. For my friends whom I've set up who aren't on Rollins, MeshCam is what I recommend. It's really, really easy. It's just drop-down menus. You can pick a whole bunch of options, and it walks you through them. DeskProto is very, very similar. That's a German company. And finally, SRP Player. SRP Player is the CAM software that ships with Roland machines. It's what I use, I'll say 95% of the time. And the reason why I use it 95% of the time as opposed to the Fusion license that I have is, and I'll say for patches, I use it 95% of the time. For other things, I don't use it. But for patches, I use it is because most organic shapes are big dumb tool paths. Each tool touches every part of the geometry. And that's juxtaposed by, um, let's say I wanted to make this tape dispenser. And I know that on this part here, I wanted to use a 1/16 inch flat end mill. And here I wanted to use a 1/2 inch ball. And here I wanted to use a lollipop mill. When you're creating widgets, oftentimes the geometry of that widget will dictate what type of tool you use. Since these are giant shapes with no real defined crisp geometry that requires a specific tool, it's basically you move from a larger tool for roughing things out and a smaller tool for finishing things. So when people ask what type of tools do you use, I don't use a lot. Like most of the time for patches, it's two, maximum of three tools. Um, this is a shot of Desk Proto, sorry, Desk Pro SRP player, and I can't see the left right side of my screen because of the zoom things, but I think I have this as the roughing screen, and this just shows the choices that I'm making. Let me actually hit escape here so I can see it. Ah, there we go. Yeah, this is roughing, and uh, on this machine, I tend to program in millimeters. In fact, I always program in millimeters on the Roland just because violin work tends to be in millimeters, and so I'm going to program a CNC machine in millimeters. Here I'm at a little over 1,000 millimeters a minute. Spindle speed is the top end of the Roland at 15,000 RPM. I'm cutting in at 0.6 millimeters, and I've got what they call path interval. Most folks call a step over. It's just shy of 2 millimeters, and I'm leaving stock to leave as 0.2 millimeters. I'm sure you guys have talked about before about recipes for cutting out things on CNC machines, and it's going to be very, very machine specific. You kind of have to play with things in order to see what works well. I've kind of determined that this recipe for my machine and what I do, and I should add, this is using a 1/8 inch or 3.2 millimeter uh, 1/8 inch ball end mill. And the type of tool path that I'm using for this is they call it contour lines. Fusion might call it 3D contour. Basically, it cuts things out looking like a topographical map, and it's going to leave that 0.2 millimeters of stock. And if I go forward to the next one, this is the finishing strategy. And I've found that just shy of 700 millimeters per minute. In fact, a lot of times I'll back that down to 600. And I'm using a cutting strategy called scanning lines. In Fusion, this is called a parallel toolpath, and it's parallel in X. So the grain lines are in Y, running in Y, and the toolpath is going in X. I found that I get the best results that way because if I run them parallel with Y, the summer growth or the white bit of spruce tends to not look as nice and not be as smooth as a job. So I always run it opposite in a parallel finishing path to what the grain lines are going. So if I were to have the grain lines going in X, I would run the parallel path in Y. At least that's what I found that gives me the best results. And you can see the step over or the path interval is 0.15 millimeters. That's tiny. I'm using a 1/16 inch ball end mill or a 1.588 millimeter ball end mill, same thing. And people often ask, don't you need a tinier end mill to do really tiny things? No, because it's not the entire end mill that's cutting things, it's just the tip. So that tip of that 1/16 inch ball end mill um, at a path interval that's at 0.15 millimeters gets an awful lot of detail. I usually only go down smaller if it's something that's ridiculously, ridiculously small, and I almost never get there. Most of the time, if I'm using a really tiny end mill, it's on something like if I'm cutting out bridge blanks on my machine, and uh, the grab this here. Come on. The heart here on the machine, unless I use a really, really tiny end mill, it is super, super hard to cut that out. So there I use sub 1 millimeter in order to get in there to make bridge blanks. But otherwise, 1/16 or that 1.588 millimeter ball end mill is fine. Usually, most of the time, I'm using 2 or 3 flute end mills. Um, Most of the time, it's just two, using just carbide. I buy stuff from McMaster. I'm not buying anything fancy. It just works. So let me, and here we see a parallel toolpath. Software costs. Mesh cam, it's $250 for the standard license. Very easy to get started with. You can download a trial. I believe the trial lasts for like 2 or 3 weeks, so it's a generous trial. Desk Proto, that starts at 145 euros. Some people like it over mesh cam. Incidentally, if you're looking to get into um, multi-axis machining, so the CNC machines that are over with the robot employees there, those are 3-axis machines, meaning X, Y, and Z. When you start getting multi-axis machines, you're starting to add a fourth axis. For instance, like James Rodman on his Obsidian has a fourth axis. That's a rotational axis. We call that the A axis. If you've got a machine with a fifth axis, that adds a B axis. Um, and those are really useful if you're trying to avoid undercuts. For most, or avoid multiple setups and have problems with undercuts. Most things that we're doing with repair and restoration work, that's not so much an issue. For making instruments, there's a company in Australia, Sydney Strings, Glanville Violins. They have a five axis machine that they're using to rough out or actually take to a very high level of finish violin scrolls with. So Desk Proto is an inexpensive way to get into multi-axis machining. Their multi-axis license starts at, I think, 1,000 euros, which is pretty cheap to own that. It's not continual 4 or 5 axis. It's indexed, which means that here's the workpiece, here's the cutter. The workpiece moves, moves, moves. It's not continual, which for objects like violins or guitars is 100% fine. I can't think of any machining process involving an instrument that would benefit from continual 5 axis, but I could be wrong. A lot of peg makers. There's a peg maker in Germany called Berdani, and I got to laugh every time that they say handmade because um, it was about a year ago that they stopped putting up photos of it coming off the fourth axis machine because it just doesn't make sense to do this stuff by hand at the scale you need to in order to make a living at it. I mean, they're finishing the stuff off by hand, but it's a fourth axis machine that's making it. Hobbyist license for Fusion 360 can also do this well. However, excuse me, the first time you open up the cam environment in Fusion, it's a lot to wrap your head around. After you've used it for a little while, it gets much, much easier. But that first time you open up the cam environment, you're like, what the heck am I doing? Um, the hobbyist license also restricts things from a cam perspective, unless you want to go in and edit the G code by hand. But for instance, it slows the rapids down of your machine. Rapids are how fast the machine moves from point to point between cutting operations. It also disables it if you've got an automatic tool changer. My Roland MDX50 has an ATC, and the hobbyist license just wouldn't work. The hobbyist license also limits you to 10 open documents at a time, which is fine. You can learn a little work around that. For me, uh, Fusion is also something I do to create with, so I want to have more than just 10 documents. So I those are some of the reasons I pay for a license. Here's our finished part. Uh, it could turn out. I was not exactly pleased with this as I could be. This spruce did not mill the best. Not all spruce mills the nicest. So what I would do in the beauty of CNC, if I really wanted to make sure this was a nice job, which by the way, this would work 100% fine, is I would pick out another piece of wood and I would mill it again. Because this took all of about 20 minutes to mill. So for the amount of fuzz that's on it, which really isn't an issue except in my own neurotic brain, um, I could do it again or I could let it go. And that's kind of one of the beauties of this sort of technology is if you fail, you can view it as an iterative process. You can do it again and again until you get it right. Same things with grain alignment. There's been times where I've had through patches that go to the outside that I just don't quite nail. And so it's like, well, that's a little off. And if I did it by hand, I might have kept it. But since I did it by machine, I can just go and run it again until I get it right. So that's to me, the real beauty of it is the conservative nature of it. And it's also the fact that if I screw up, I can just do it again. And I didn't lose a whole lot of time. Time when you're a restorer is your enemy because a lot of times these processes take so long. It's nice to have something that if things don't go right, you can do it again and relatively quickly. So this is a fine workable patch, but for me and my own neuroticism, I would probably run it again with different spruce. Machine recommendations. This is probably the part that's going to be the most controversial by people who know things about CNC machines. But when I came up with these recommendations, they were for people who have violin shops. Violin shops don't necessarily have a whole lot of room. In fact, I've never heard a violin shop owner say, I have extra room. It just doesn't happen. These are small machines. These are desktop machines. People who are used to industrial machines will call them toys. And by comparison, they are. If you've ever been next to a Haas VMC that weighs 6,000 pounds, these things are essentially toys that are on this screen. So my budget pick, the Nomad 3 from Carbide 3D, it's 2,800 bucks. It does an 8 by 8 by 3-inch area. I believe it's available worldwide, even in the UK. It's got a tool length sensor on it. It's 2,800 bucks. It might be a little noisy, but it'll get the job done. I've seen some pretty amazing things made with it on YouTube. You can see a lot of these machines on YouTube. The Bantam Tools Desktop and Explorer, 8,000 and 4,000, probably a little pricey for what they are. In fact, there's a guy on YouTube who's made it his seemingly life mission in order to bash these machines. But again, he's comparing them to industrial machines. For what they are, they do really, really well. In fact, if I could afford the Explorer just to have it as a teaching machine, I would probably buy it. It's so small. It fits into a Pelican case. It'll do a 4-inch by 6-inch area, which, by the way, most of the patches I've ever done, the things that have solved the biggest problems have not been large things. I bought my MDX50 because it was the thing with the biggest cut area that I could squeeze into my tiny shop. And I've never used its full cutting bed. It'll do an area that's 15 and 7/8 inches by 12 inches. I figured I'd want to have something big enough to do a cello chest patch, and I've never done it. I've never done anything super huge because most of the time the stuff that solves problems tends to be very small, that allow you to get working back in a way that you're familiar with. Even doing edge pieces, like the edge of a cello, I had this envisionment of doing like massive entire pieces of cello under edge. And the reality of a lot of tear out on cello is that it's not the entire piece, it's segments. And then you're back to material that's not touched. So again, small things equal big results when you're trying to be conservative or you're trying to save time. Another great machine, if you can find it, my good friend Elian LeBlanc has this one, is the Evo 1 by Maker Dreams. This was kind of the the dream machine for people looking for something with a lot of horsepower in a small package. It was made, notice the was, in outside of Venice in Italy. The guy who owns the company is a sweet guy and super great tech support. The problem is right now is he has a business partner that they're trying to get out of their partnership with, which I think has pretty much sunk the company. It's a great machine if you can find one on the used market. It's got ball screws, a powerful spindle. Um, it's good stuff. It's just it's a shame that the company is going through some stuff. It might become available again. I've seen them for sale on eBay and on Facebook Marketplace occasionally here in the States. 4,600 euros. It's a good deal for what it is. Avid CNC. They make CNC kits. They have a router that'll do a 2 foot by 2 foot area as their benchtop pro. I think I last time I priced it out, you could put a system together for around 8,000. And finally, the Roland MDX 50. Uh, I would buy this again in a heartbeat. The reason why is for doing violin work, it works exceptionally well. It's a good size. It's extremely quiet. It's got an automatic tool changer with it. The it's very, very smooth operationally. It's a champ. I bought one, then Chris Rooney bought one, and then a whole bunch of other friends bought one. They're not cheap. The thing that you need to do if you go this route is you need to get the door safety interlock switch. Um, what happens without the door safety interlock switch is you open the machine lid up and the spindle locks, which means that if you want to position your stock, if you want to run a dial indicator or do what I did with the alignment pin and light behind it to check parallelism, you can't do it. So there's a company in Chicago. The company's down to one guy. He's semi-retired. It's called Cybrid Systems. His name is Ward Townheiser. He makes these switches that you install that defeat the door safety interlock. Um, so if you buy one of these, you need to contact Ward and buy the switch, or just buy the whole machine directly from Ward. Um, he's a great guy. He's the person in the States that I've discovered that knows the most about these things, and he's in his 70s. So like take advantage of Word all you can. So it's expensive, but for restoration work, it's kind of the best thing. Be warned though that it is not rated for metal. I like to make things. I like to make tools. It's becoming more and more a part of my business, or it will be part of my business to make tools. And that's an outgrowth of being involved with this technology. Like I learned that I have an affinity for CAD and CAM, and it just fits the way I work. And it killed me that the MDX 50 is not rated for metal. It handles engineering plastics like Delrin or polycarbonate very, very, very well, but you can't do aluminum, brass, or steel with it. And that's why I bought a second machine, the same one that James has, the Obsidian. Um, the Obsidian, which by the way, could also handle patches very, very, very well. It's just an open machine, and dust collection is going to be a problem. Like metal chips are a problem with the Obsidian. However, man, like aluminum chips are not the same as dust filling your lungs. So having an enclosure or a dust collection system really is necessary when you're doing this sort of work. Special considerations. Anything that you would glue in a cast, you need to scan in a cast. This sometimes requires the use of vacuum bags or a cast made with compressible material. This photo is courtesy of a friend of mine, Jimmy Dugdale, who has a similar setup of mine with scanner and MDX 50. What I mean by that, if you're going to glue it in a cast, you need to scan it in a cast. At this point, it was about a year and a half ago, 2 years ago, there was a shop in the western part of the United States that very proudly posted a picture of a soundpost patch that they had scanned. And soundpost patches, you take them down, so there's in the patch bed. So there's like 0.3, 0.4 millimeters and a top that is, and a back. Sometimes you go less material, original material left. And they were very proud of that they scanned this soundpost patch. But they didn't take into consideration that the patch bed lifts off the cast when it's missing, starts missing material. When you start excavating it, it lifts up. That's why when you fit a patch by hand, you're doing the last little bits under clamp tension, and the clamp tension pushes that lift off back down into the into the cast, and it helps transfer chalk. They didn't do that. They didn't use a vacuum bag. They didn't use a compressible material, and you could see the lift in the patch where it matches the potato chip shape of the patch bed uh, in the picture that they put up next to it. So you need to think, how does that wood behave when you need to glue it in a cast or when you remove original material. So my general rule of thumb is, if you're going to glue it in a cast, you need to scan it in a cast. And that's why a lot of us have gotten vacuum systems. Um, Jimmy's got one. This is actually he's moved on to something slightly different, but this is actually a sweater bag that you go to Walmart and you get the giant bags to compress sweaters and coats down into. This is one of those. He's since modified it with stretch lawn. He cut out a window and used special adhesive tape to put stretch lawn in place, which gives much more accurate results. Finally, the dangers. And this is kind of universal. Just because you can do something doesn't necessarily mean that you should. I mentioned before about the the upper neck block that I made fit the back of the instrument. I could do that, but later I realized that I probably shouldn't do that. Um, Likewise, you can find yourself doing all kinds of crazy things now just because you couldn't do it before. One of those things, one of those dangers is getting patch happy. More patches, the reason I wanted to get into this technology was to be more conservative. More conservative isn't putting in a patch where it isn't needed. So it's really tempting sometimes. It's like, oh, I can just add thickness there by putting a surface patch on. Well, does it need it? No. In fact, something like a strap cleat might be better than just putting a patch in place. Technology is only smart as the user. I just gave the warning about the folks who had the soundpost patch where you could see the deformation in the patch bed. Um, it's not the technology's fault. It's the user. That's entirely his user error right there. And lastly, getting CNC drunk. I know people that are making fingerboards with CNC machines, like fitting them and fitting bass bars with CNC machines, or just doing the most stupidest of stupid things. And I'm like, I love this stuff. It's fun, but at the same time, I realize that if the machine isn't serving you, if you're serving the machine, it's the wrong way around. There's a lot of processes that you could get imaginative with. You can say, "Oh, I could do that with a CNC machine," but really, should you? And the answer a lot of times is no, you shouldn't. But it's almost like this drunk power sort of thing. And I've done it. I see people now that post things that have done it. Um, and a lot of times those people that have gotten back to me later, and they said, "Yeah, you're right. I kind of went overboard." It's like, "Yeah, you did." So that's the danger of this technology. It's just because you can. It's like, oh, it's fun, but it might not necessarily be the most prudent for time or for process. Um, so I think that's important to remember that. That's it. That's what I got. I can answer questions. I can show you things. Uh,
That was fantastic. Does anybody have any questions?
Um, Jerry, is there any chance you can pop? I don't know, like, can you pop Fusion 360 open and maybe show the orienting or your orienting process and your machine, or is that too crazy?
I'll see what I can do. I don't usually use this computer for orienting. Let me see if I can. Let me open up Mesh Lab here and see if I can remember.
Yeah.
Second. Hold on. I think the only file I have on here is um it might already be hold on, I'll find something. Okay, let me share screen, share. Oh, if I can see this. No, the bar is covering. How do I get that bar to move? Does anybody know how I get the toolbar to move? Oh, there we go. I just grab it. So there's this patch. We're going to go to normals, curves, and orientation. We're going to go down to rotate. And what you do, we're going to do preview. And we're going to, oop, this is kind of
Oh,
dragging.
okay.
Yep. Let's go to Y. And we're going to go.
So there's no floor in that program, or
No,
is the
MeshLab is
floor
just
on?
in MeshLab is just floating freely.
Okay.
I'm gonna hit apply. Come on, don't be draggy. Work done, you work. Now, there we go. And let's go to normals, curves, and orientation. Let's go to and translate. So translate I use here. I don't usually use it. A lot of times I use that. This is what I want. That's not it. Yeah, not the command I want. This is like performing on the spot.
Oh, I didn't mean to put you on the spot.
Translate. No, it's gotta be rotate. Back to this.
So can you change the origin point of that object?
Yeah,
How
you
is
you can. You can. I don't necessarily. There we go. That's what I was trying to do. And
oh,
close. Yeah, you
so
can.
so the y-axis of the world origin is the
You can move everything independently. Well,
okay.
let me get out of this. Again, a lot of times I use that really simple program that's not on this machine. And I don't think Fusion likes being on. Oh, there we go. Oh, get out of my way, bar. Going to go insert mesh on the computer. did you go? Nothing like watching somebody search for something online.
The demo, yeah.
Okay, so to move it, in Fusion, it's kind of dead simple. You just rotate it however long you want. You just grab the right trackball and just turn it around. And then you can see kind of how it's looking, like I'm a little cockeyed there. And you just screw with it till it looks right. It's pretty much all it is. It's no real secret. And move this around. That's probably pretty good. You just move it around the pivot till it looks good.
Cool.
But if I switch to go to my phone here.
Do you want me to switch to your phone view?
Yeah. Okay. Go to my where's the Zoom app? Okay. Second. A lot of times I use this is really low tech here. Go to if I'd known I'd done this, I would have set up something a little easier.
Barry, do you ever mess around with Blender?
A little bit, not much.
Iris, how are you feeling? Are you feeling like it's doable? I know it's late as all get out there, isn't it?
Yeah, it's 9:30 here. Yeah, no, it's I think it is doable. Now I'm wondering whether to buy all the equipment and then then the BBMA invites Jerry over and he can show them my equipment.
You need to get the equipment, and then you need to trick a young person into being your intern.
Yes, that did cross my mind. That would be a good idea, I think. Yeah, a very technically minded person.
So a lot of times I'll use this and I'll just go to object rotation and I'll start messing around with it and I'll go to put in a degree function and I'll literally work it around that way in order to get to let me see if I've got nope, cancel. I apologize. If I know how to do this, I would have
Rehearsed?
I would have rehearsed.
No, I'm sorry. I didn't mean to put you on the spot.
That's okay. Front.
Do you have to modify those pieces at all when they come off the machine? Like, do you have to take a knife and give it a little Bob's your uncle or on
No.
a spot here and there? No, just
No.
Legos right in.
Yep. If it doesn't, I've screwed up something.
Uh,
It really doesn't fit then. Anyway, you get the idea. I apologize.
no, it's okay.
This is tough to do on the spot for me. I would
Yeah.
have rehearsed. Whoa. Anyway, this is the while we're doing this. Normally, we should talk a little about scanning environments. Darker is better. So normally this is about the ambient light level that I want. I'll turn this off and go over to computer here. Close this. No, cancel. Don't want to save you. No. And a lot of structured light software, or a lot of 3D scanning software lets you know how much light is being saturated. And this does it by these red lines that look like heart rhythm strips. You can see here it's almost being blown out. If I increase the light on the projector, they're really giving me, it's flattening out here. What that'll do is that will equate to giving me washed out data. So I'm really mindful of the amount of light that I have on this thing. And also usually what I'll do for this is the angle you intercept. Yes, I don't need to catch all the question. The angle that this is coming in at does make a difference. A lot of people have issues that they will try to get it so that the head of the projector will be vertical down onto it. And the problem with that is there's no depth there for the machine to read. So it needs to come in at an angle. If it comes in too straight, you'll get false readings. So yes, that does make a difference. Whoever asked that. Also, the angle between the projector and the camera or cameras, I have a dual system. That makes a difference too. If it comes in too straight of an angle, it doesn't give you, it gives you false readings. Usually the calibration portion of the software will fix that, but in this instance, it's just it's pretty straightforward. Where that target dot is, I usually put the camera there, and that usually gets me somewhere around 20 degrees. This has a little scale there that helps to keep track of things. Incidentally, the calibration, you don't need to calibrate it every time. If I were to leave this out on my bench, I won't calibrate it, particularly if I'm doing a lot of this stuff. I won't calibrate it every time. But when I'm not using this, I have this rigged up on what is my microscope boom arm. And I just have a little adapter that I machined for this is the camera tripod head that goes into where the microscope normally would. And I just pop it out when I don't need it and I put it away in a drawer. And then when I take it out again, I'll recalibrate it. Because sometimes I can go for weeks without using this. But when I use it, I tend to use it a lot. What the microscope boom arm does, these are usually sold with tripods. Tripods are a pain in the ass in order to get so they function with instrument plates. So you get the right distance, the right angles. So I really found that a microscope boom arm is the way to go for this sort of stuff, or some sort of articulating arm. You can buy articulating arms for monitors, for keyboards, for all kinds of things. It's just so much easier. I don't know. What else do people want to see?
I don't know.
I'd be quite interested in the minimum requirements for the computer you're using, like the RAM, etc.
Okay, so that's gonna. Ian, you want to take me back to
Yeah.
my spotlight me?
Yeah.
Okay, am I good to go?
You're good.
Okay. So minimum requirements. That's going to depend a lot on the system. For this scanner, it's got a couple different requirements. The one that's tough to do in this day and age are the number of ports it needs to have. This needs at least 2 USB ports and an HDMI port. You start looking around at computers, and that seems to get tough anymore. Also, the requirements, you need a graphics card of some kind. Most modern graphics cards are are going to be fine. And what I mean by a graphics card of some kind is when you start looking at computers, you'll oftentimes see like integrated graphics. It doesn't have a separate graphics processor. So you need to have one that lists like NVIDIA or AMD or something along those lines that handles graphics. For this scanner, and for most scanners, more RAM is more better. That I've got 64 gigs of RAM in that, which years ago used to be stupid expensive, but nowadays RAM for a PC is kind of cheap to add. So I've got that in there. Processor speed, it doesn't seem to matter so much, but with other ones it does. Like there's a great little scanner made by Einscan called the Einstar. I don't think it's necessarily right for violins, but I don't know anybody who's been able to test it, because even though it's a budget scanner, it costs about $1,000 for the scanner. The specs that are needed for the PC to run it are astronomical, like 128 gigs of RAM, Intel Core i9 with a very high clock speed on the processor, really specific graphics card. Like the PC you need to run it costs $5,000. So I don't know anybody who's tried it, just because the PC you need to run it is so stacked that it's no longer a budget unit. I would think most 3D scanners are going to list, or in fact, they're all going to list what the requirements are.
Mhm.
Since if you go to the Transcan and you look up the requirements there, it will list what you need to run it. And
Okay.
you would either get that as the minimum, or you would try to better it. And better it usually means a faster processor, more RAM, a newer generation of graphics card. So they'll list
Okay.
it, match it, or do better.
Thank you. That's great. Hmm.
Next
Anybody
question.
else? Oh, well, that was really fantastic. That was a very thorough explanation.
Oh, glad
Really,
you liked
really nice.
glad you liked it.
Can
I mean, I don't have anything set up on the MDX50, but if you wanted to see the ATC work on it, I could jog some tools around. Otherwise, that's kind of what I got.
I think that's good. We should get some tools running at some point, but I think that's good for today.
Yeah, I can do that at another time. I can plan to have files up that I've rehearsed with,
Yeah.
and I might consider putting Zoom on that workshop PC. As I mentioned to Iris before we got started, I have two workshop PCs in here, actually three, counting the one that runs the Obsidian. I don't put them on the internet like at all. Like I have them set up, I have them ready to go. And the reason why is when you start running particularly PCs on the internet, you tend to need antivirus software. You need all kinds of things in order to keep them safe. And you're also prone to automatic updates. And stability is one of those things that I think is key. Once you have a system that works, you don't screw with it. And I learned that from years ago. I used to do studio work playing as a violinist, and I would go into these studios, and you would see like the most ancient Mac or ancient PC running their digital audio workstation, and that was because once they had it stable, they didn't screw with it. And I kind of adopted that philosophy with my workshop computers. Is once they were stable, I wasn't going to do anything with it. Just to keep them as good as I could for as long as I could.
I do the exact same thing.
Yeah, the way to go.
Yeah.
Can I just quickly ask again about the automatic tool changer? Is it basically two different type of drill bits? You use the 8-inch and the 1/16. Is it
Yeah,
usually
okay.
two of them?
You want to hit me up back to my phone?
Yep. Come on.
Over here. Most of the time, most cutting is done with a 1/8 inch. Can you hear me?
Yep. Little,
Okay.
little dry, but it's okay.
Okay, yeah, most of the time I'm using a 1/8 inch 2 flute ball end mill for roughing and a 1/16 inch or 1.588 millimeter ball end mill for finishing cuts. The ATC isn't necessarily anything that you need to have. It is convenient. All I have to do here is if I want to pick up a tool. Right now, what it's doing is it's measuring where the end of the spindle is. As who knows, it might have changed. And now I'm picking up a tool. Now it's going to measure the tool again, or for the first time. And that's it. It'll do that automatically when I'm running the program.
Excellent, thank you. Yeah,
Yeah.
that's amazing.
I don't know, Iris. I think you got to get one of those.
Well, I have kind of started saving up for it like over a year ago. So
Yeah, look at
that
that.
was the CNC I was gonna get. I wasn't so sure about the scanner. But that was very helpful today to hear about the scanner. Jerry recommends as well.
So you don't necessarily need. It's a great machine. And I think what people lose track of, and I've recommended this to a lot of people, we have a mentality, particularly in the violin trade, when it comes to tools, where we're told to buy really nice things. You know, buy a great chisel, buy a great plane. It's going to be expensive up front, but you'll cry less about it later. I spent my first CNC machine that I got, which is, this thing here. I spent $1,100 on that. That was education. That was a low entry point to get into it. And I think that's really valuable. Get something that doesn't have a huge price tag and screw up. That's really, really hard to do, is to get something and know that you're going to screw up. But it's a lot easier when it's cheaper. Same way, the other thing I tell people to do, and nobody is taking me up on this, is rather than going out and buying a CNC machine, is you go out and buy a 3D printer and learn how to print stuff. Learn how to work inside a computer, because it's safer, it's cheaper, it's faster. And once you take those baby steps, you can then go get a CNC machine and everything becomes easier.
I mean, one of the most attractive things for me about getting this machine is that you've got it and quite a few other people have got it and know it.
It is.
If I get some random machine, okay, that costs me half the price, but nobody's ever used it and doesn't know how it functions, I've got nobody to help me. So that to me is a huge factor.
True, I can understand that. But there's there's got to be stuff where you can go to a community college and you can learn just basic CNC stuff. There's got to be something like that.
I guess one of the main problems is we all, nobody has a lot of time really. And while you're messing around with learning how to 3D print, I'm not getting paid. And it sort of seems we kind of want to jump in and be able to do it straight away. And it's kind of, you have to get your head around investing a lot of time and learning. And
that is part of it. So, restoration is a design process. And part of the design process is iteratively screwing up a lot. And there's no getting around that. If you go out and you buy a machine, regardless of what machine you get, you're going to waste a lot of time just getting your head around it. So, you can do that in small increments. One of the things I love about digital tools for anything is I spend a lot of time not being able to be in my workshop because of family constraints. I can sit at my kitchen table. I can sit on my couch and I can design things. I can play with files. I can do all kinds of crazy things that aren't in the shop. So I get it. I get the understanding to wanting to get this machine. If you do get the MDX50, you need the switch. The switch with the door safety interlock is 100% must. I don't even know if the folks at Rooney's got it because I told Gen about it. I don't know if they got it. Everybody else has though, like
I
Jeff.
think he did mention it, that it was a requirement that you need to be able to.
Yeah, yeah. If
That was the other thing I was going to ask you. You mentioned this guy's name, but I don't know whether.
I'll just send me a message. I can give you his email address.
Okay.
Uh, you can he'll ship that to the. If he won't ship it to the UK, he can send it to me and I'll ship it to you.
Thank you.
Which obviously the guy buying a machine from him would be tough.
They have got a place. There is actually a place in the UK who sells these machines.
Yeah. I think the head guy there, his name's Patrick Robbins. Patrick. Anyway, he used to have a whole bunch of videos on the machine that you could watch. But yeah, there are Roland dealers in the UK. It's 300 pounds. It's not tiny. It's an odd size. You're probably going to have to build a custom table to sit it on, unless you've got counter space that it'll sit on, because it's bizarre.
Oh, right.
Yeah, so that be warned about that. But yeah, just the size. It took 4 people to move it in here.
Jerry, do you have a sense if, like, Iris was to grab a machine and grab the scanner now, like,
Yep.
Like the failure is like an investment in the future, like all of that failure. But do you have a sense of like what a sharp person kind of going hard at it, what their end date is for being able to produce the results that you're producing? Like, do you think like a year from now?
Oh, no, it's going to be a couple weeks of misery.
Yeah.
If it was only 2 weeks, I'd definitely.
It's a few weeks.
I think he's saying 2 weeks of hitting it real hard, though.
Like, yeah, 2 weeks of hitting it real hard, but like maybe a month of real misery. It's not bad. A lot of it is it's just a lot of different pieces that you have to put together, and there's different ways to get to the end result, depending on what your budget is, what you're comfortable with. What scanner you get. Everything has its own little intricacies to learn, but it's still all the basic thing of data capture, data manipulation, making it right with the world, cam, machine setup, cutting. It's all the same process. It's just every little piece of that's going to have a little twist on it depending on what software you get.
It would seem to me like starting out with the CNC machine, you'd want to start making some simple items that are not scans to start.
Yeah.
Something to, get up and running.
Practice pieces.
Yeah.
The other thing to keep in mind, Iris, is software is probably the cheapest part of this whole thing. You can get software for free for a couple weeks, and then you can choose to pay for it. But of the whole process, the software is the least expensive thing you're going to buy. So if you start playing with it for a while and decide it's not for you, you're not in deep. Whereas when you start buying hardware that you're not using, that's collecting dust because you're not up on the software, you're going to start kicking yourself in the butt because you spend a bunch of money that you can't use.
Yes, that's a very good
Also,
point. Yeah.
I didn't hear Jerry mention it, but I use a CAD CAM program made by Vectric in the UK. Actually, it's called Aspire.
Aspire,
Well, I
yeah.
use Aspire, which is the 3D version, and you could, Iris, they offer a free downloadable copy of that that's fully functional, except for actually creating the toolpath. So you could get a real good sense of that software. It's not cheap. I think it's, you know, you buy it like some of the other ones. It's not a yearly license fee, and I think there's a new version coming out actually this week, and I think it's $1,700. So I have found it incredibly intuitive, particularly on the CAM side. You know, the CAD side, it's different, you know, in terms of 3D modeling than Rhino and a lot of the programs, because it's not based, it's a point cloud thing, and it's not the, you know, the, what did you call them, Jerry? You know, mesh. Yeah, it's not a mesh, but there's a terrific user community that's very active in terms of helping people. So I would look at that, because you have the opportunity to download it for free and use it, you know.
So
What was the name of it?
It's made by Vectric. It's the 3D version is called Aspire. The 2.5D version is called VCarve Pro.
Okay, thank you.
so when you buy an MDX50, it comes with a license with that.
Oh, wow. You
Never
get that
used
for free? VCarve or
It's a $10,000 machine. They give you a lot of things for free.
Yeah.
That was one of them.
I
But
didn't know that.
That too.
I've never used it, because if you get an MDX50, it comes with SRP player, which is stupid simple. So, Iris, you've known me for years. You can call me at absolutely any time. You know that.
Yes, I do know that. Thank
Okay,
you.
then buy the
Yeah.
machine, Iris. Get the machine.
Well,
Get the
it's
machine.
yeah,
Get
it's
the
just
machine.
whether, because like with me, I mean, I do have a lot of patience with certain things, like, you know, obviously my restoration work and everything. When I sit in front of the computer and do my accountancy work, like I have the software program QuickBooks, for example, where I have to categorize things that come into my account or things that go out and come in. And I mean, honestly, I hate it so much, you wouldn't believe it. It's like I hate it, you know. So I don't hate everything to do with computers. I just kind of have to work out if I have the patience to,
It's
because it's
totally
obviously,
different.
yeah, hopefully.
It's totally different.
Yeah.
I am not very good at doing anything with my own website. I am not very good with QuickBooks. But because this has a real world application, it's a whole lot easier for me. Like I can.
That's very true. It's actually, yeah.
Yeah. 'Cause
When
I
you get your
noticed in-
Oh, go ahead. I'm sorry.
No, go ahead.
I was just gonna say, when you get your first spruce Lego popping out of that thing, like there's a lot of like, I bet there's a lot of dopamine involved in that.
Yeah.
Not like, you know, like figuring out your taxes.
No,
Yeah, I know. It's just it's the worst thing for me ever. So yeah, I mean, I get very excited when I see all this stuff, you know, what people are able to do. Especially because actually one of the things I thought I'd really wanted to get into it was that like what Jerry was explaining with the edge tear out. It's a job I really don't enjoy doing by hand. I really don't like doing that.
It's the number
so
one
that's
thing. It's the number one thing I use it for, is edge tear out,
Yeah.
because there's so much of it. So much of it. And that's actually the easiest thing. Like you don't have to be careful with a lot of it. I used to make a counterform for everything that I was going to do it with, but now it's just, oh, there it is. And it's very, very fast. Like I can do the entire under edge of a violin probably in a day.
Wow, that's amazing. I mean, if I could just literally use it for that, I'd be quite happy,
Yeah.
I think.
Yep. You could.
Yeah.
Because
Yeah.
it's not that bad.
Mm.
And we can always, again, like I said, you can call me anytime. We can do you and I over Zoom. We can totally do that.
Yeah, no, that's an amazing offer, and I'm very, yeah. I mean, that's kind of, you know, that's a big boost to my confidence knowing that. It's just, I mean, I'm kind of finally catching up on a complete mountain of restoration work that I sort of completely mismanaged my workload last year. I'm finally sort of catching up on myself, so I haven't even been able to think about it. But maybe now that I'm sort of on my last project that I've had since last year January, I kind of feel maybe now is the time soon to at least start thinking about it again. And yeah, I think start with learning the software is probably not a bad idea, first of
But
all.
software on its own, you almost need something to play with first. So if you're
Right,
going,
okay.
you know, the scanner is if you're going to do the combo of Transcan and uh the Roland MDX50, you know, the Transcan is the lesser of the two cost wise. And you could probably, if you hated it, you could probably always sell it reasonably quickly for what you put into it.
Yeah.
I'm not familiar with the Transcan as much as, let's say, Dan Gillespie is, but you could call
Okay.
Dan Gillespie. That's the
Yeah.
machine he has, and Dan's doing great stuff with it.
I appointed him my PA today, actually. I'm talking about Dan. I was trying to get hold of Antoine at the Chicago school, and he hadn't looked at his WhatsApp for about 2 weeks. And I thought, I don't know, maybe I've got a wrong number. So I texted Dan,
Yeah.
and he said, no problem, I'll get him to, to get in touch. And he called me within 2 minutes. Antoine, and so I said I sent Dan a message. I said, can you please become my PA? Organize all these, when I can't get hold of anyone or anything. So yeah.
Dan knows the Transcan very well.
Okay, that's brilliant. That's good to know. Yeah. Nice one. Yeah. Right. Takes just some courage, really.
Well, guys, go ahead. I gotta get going.
Yeah.
But I wanted to before I go, could everybody unmute and tell Jerry thank you for this great demonstration?
Yeah, brilliant.
Thanks,
Thanks so much.
Jerry, really appreciate it.
Thank you, Jerry.
Thank you, Jerry.